We are able to calculate displacement from velocity by multiplying velocity with the change in time. Now, some of you may have done this in physics, in that we have a velocity time graph, and we can actually calculate the displacement by taking the height of that graph times the displacement, or sorry, the change in time, and that will give us the area underneath the graph. So when we say that we have this velocity function v equals 2t plus 1, so that represents the height of that red line. The part of the diagram that represents the distance traveled is going to be these blue rectangles. Because if you take a look at these blue rectangles, the blue rectangles have a height, which is velocity, and they have a width, which is the change in time. So each one of those rectangles must represent some displacement. So we're going to use this property then, that velocity times the change in time is going to give us displacement, and we're going to use that calculation to find the area underneath that velocity graph and estimate the displacement. Now, I say estimate because you can see that there is this little bit of mismatch in here of the actual area calculated, and the actual area underneath that velocity function. Okay, so that we're going to have to resolve that at some point. But in general, that rectangular area then is going to represent our displacement. And the total displacement is when we add up all those areas. So looking at that first area, we have this height. Looking at the equation, the height, the y-intercept is 1, so we're going to say that that height is 1, and each one of those rectangles has a width of 2, so that's going to be 2, 4, 5, 6, 8, like that. So in the first 8 seconds, we can see that we have a displacement. That first rectangle, so the displacement is going to be equal to 2 seconds times 1 meters per second. So that's going to be 2 meters. Okay, so this is going to be 2 meters here. The next rectangle is going to have a height of, it looks like 5 meters per second. Just a width of 2 seconds. So it's going to be 5 meters per second for 2 seconds. That's going to be 10 meters of displacement. So this can represent 10 meters. The next one looks like it has a height of 9 and a width of 2. So 9 meters per second for 2 seconds represents a displacement of 18 meters. And then that last rectangle looks like it has a height of, at that point, it looks like it's a height of 12 and the width of 2 seconds. So 12 meters per second times 2 seconds is going to give me a displacement of 24 meters. So the displacement up to 8 seconds, we can estimate that's approximately, looks like 2 plus 10 plus 18 is 30, or 54 meters. Okay, and that's positive velocity, so we can also say it's positive 54 meters of displacement.